Hi students, this is the final session of atomic structure lessons. Okay. So, now we are going to see about the isotopes. It is a new topic to you. Isotopes. What are isotopes? The isotopes are the atoms of same element, okay, which have the same atomic number, but it has the different mass number. The atom of the same element which has the same atomic number, but it has the different mass number. Okay. How it is differ? Mass number, how it is differ? What is mean by mass number? The mass number is nothing but it is the sum of the proton plus neutron. You know it already. Okay. You just see the board. Here I written three things. Hydrogen isotopes. Hydrogen having a three isotopes. One is 1H1, which is known as a protium. Another one is 1H2, it is known as deuterium, and 1H3 is known as tritium. Okay. So, hydrogen having a three isotopes, one is a protium and another one is a deuterium, third one is tritium. Okay. So, both these three case, okay, three of them having the same atomic number. What is the atomic number? Is equal to 1, but the mass number is differ. Okay. The protium possesses mass number 1 and the deuterium possesses mass number 2 and the tritium possesses mass number 3. So, now we want to calculate the number of electron, proton and neutron. From the atomic number you know the number of proton and electron. Okay. All the three isotopes having a same number of proton and electron, which means 1 proton and 1 electrons. What about the neutron? Okay. How can you calculate the neutron number? Mass number minus atomic number. So, 1 minus 1, 0, 2 minus 1, 1 and 3 minus 1, 2. Okay. So, 0, 1, 2 are the neutron numbers were present in the respective element. Okay. So, how the mass number is differ means it have the different number of neutrons. Okay, different number of neutrons. So, the atom of the same element with different atomic mass is called as isotopes. Okay, and I will give the another one example. Chlorine, Cl is available in the two different state. One is Cl17 and 35 and another one is Cl17 and 37. So, both of them atom of same element because it has the same atomic number, but the mass number is different. Okay. The first element, okay, which has a 35 is atomic mass number, and the second element which possesses a 37. So, here also the mass number is differ, but the atomic numbers are same. So, these kind of things is known as isotopes. The isotopes are the nothing but atoms of the same element which has the same atomic number, but it has the different mass number. The mass number is differ due to the difference in the neutron numbers. Okay, clear? The next one is, generally the isotopes are classified into two types. One is a stable and another one is unstable isotopes. Based on the stability, the isotopes are classified into two types. One is a stable isotopes and another one is unstable isotopes. For you just consider the first case. Out of these three isotopes, the first two isotopes of the hydrogen, protium and deuterium, both of them is a stable isotopes. Okay, but the third case, it is unstable isotopes, which is known as a tritium. It is unstable isotopes, is otherwise known as a radioactive isotopes, because the unstable isotopes which having the unstable nucleus. Okay, how it is going to unstable? Because it contains a excess number of neutrons. That is why the nucleus is going to unstable. So, these are the isotopes are called as a radioactive isotopes. Tritium is one of the example for a radioactive isotope. This is called as unstable isotopes. So, isotope generally classified into stable. There is no problem in this case. But in the case of unstable isotopes which contain unstable nucleus, so it is an example for a radioactive isotopes. It always emits some kind of rays. Okay. So, for example, CO60, CO means here cobalt. Cobalt 16 is one of the radioactive isotopes which is used in the radiotherapy treatment of the cancer. And uranium 235 is also one of the radioactive isotopes which is used in the nuclear power plant, okay, which is the important fuel in the nuclear power plant. Okay. So, these are the things which is known as isotopes. Isotopes means what? the atom of the same element which has the same atomic number, but it has the different mass number. So, the next case, isobars. You just see that the isobars are the atoms of the different element. Isobars are the atoms of the different element, but with have the same mass number. The atom of the different element with same mass number is known as isobars. You consider these two examples. The calcium atomic number is 20, mass number is 40, and the argon is one of the noble gas, you know that, okay, which possesses a 18 atomic number and 40 is the mass number. Now calcium and argon, both of them is atom of the different element, but which have the same number of mass, okay, both of them having equal mass. What is the mass number? 40. Okay. So, atom of the different elements having the same mass number means these pair is refers to be the isobars. Okay. You see that the number of subatomic particles present in the calcium and the argon. Number of electron present in the calcium is 20, because you know that atomic number is equal to number of proton or number of electrons. So, electron present in the calcium is 20 and in argon 18 electron is there. Okay. In calcium the number of proton present is 20. The same number of proton present in argon is 18. Okay. So, number of neutrons, how can we deduct the neutron number? Mass number minus atomic number. So, 40 minus 20, we have 20. So, 20 is the number of neutron. Okay. In this case, argon 40 minus 18 remaining 22. Okay. So, whether the number of subatomic particles does not equal in both cases, sir? Yes, it is differ. Electron is 20, but in this case 18. Proton is 20, in this case 18. Neutron is 20, but in this case 22. The subatomic particles does not equal each other, but you just consider the nucleons. What is meant by nucleons? It is the sum of the proton and the neutrons. So, here what is the proton number? 20, neutron number 20. So, 20 plus 20 is equal to 40. Okay. What about here? Number of proton is 18 and the number of neutron is 22. The sum of these values are equal to 40. So, the number of nucleons are equal. Number of nucleons. Okay. Number of nucleons will be equal. So, that is why atom of the different elements with the same mass number is refers to be the isobars. The third category, isotones. So, in this case, these are the elements, these atom of the different elements, atom of the different element which have the different atomic number and different mass number. On which basis it will similar? Okay, you just observe the example. Carbon 613, nitrogen 714. These pairs are refers to be the isotones. Okay. Sir, here atomic number is different, sir. Carbon possesses 6, sir, nitrogen possesses 7, mass number is also different. How you are saying that it is in the category of isotones? Iso means similar. You already told, sir, iso means a similar. On which basis it will similar to each other, sir? You just see the subatomic particles. Okay. In this electron, in this case, carbon 6 electron is there, in nitrogen 7 electron is there. In carbon number of proton is 6, nitrogen number of proton is 7. The number of neutron, mass number minus atomic number, 13 minus 6, 7, 14 minus 7, 7. So, in both the case, the number of neutrons are equal to each other, similar to each other. The number of neutron present in both the elements are equal. That is why it is refers to be the isotones. Atom of the different element with the same number of neutron is refers to be the isotones. So, these are the three important things: isobars, isotopes and isotones. Okay. Isotopes means atom of the same element which have the different mass number. Isobar means atom of the different element which have the same mass number. And the third category, isotone, means atom of the different element with have the equal number of neutrons. Okay. So, the next content or next topic is a law of chemical combinations. This is not a new topic to you. So, you are already studied in the 8th standard itself. Okay. So, how the chemicals react each other. So, some of the laws is proposed by the scientists. So, first two laws you already studied in the 8th standard itself. So, I will move on to the third law. It is a law of multiple proportions. It is proposed by John Dalton. Okay, the law of multiple proportions. It explains how the chemicals are combined each other. It is proposed by the John Dalton. So, you just see the statement. When two elements A and B, okay, are combined each other to form the more than one compound. Okay, when A and B, whatever it is, okay, it will combine each other to form a more than one compound. Okay, the mass of A, which is separately combines with the fixed mass of B. Okay, so now I will explain some examples here, then you clearly understand the concept. I will write here two compound, one is a carbon monoxide and another one compound carbon dioxide. Okay, so you assume that both the compounds is made up of same elements. Okay, it is the combination of the carbon and oxygen. The carbon dioxide is also the combination of the carbon and oxygen. Okay. Now, let us consider the mass of the carbon present in carbon monoxide. Okay. The mass of the carbon is 12, you know it. Okay. So, 12, the mass of the oxygen is 16. So, in carbon monoxide, the carbon and oxygens are combined in the ratio of 12:16. The next one is in carbon dioxide. The mass of the carbon is 12. Here mass of the oxygen, you know it is a 16. But how many oxygen atom is here? 2 oxygen. So, total mass of the atom is 32. So, the carbon and the oxygen, they are combined in the ratio in carbon dioxide is 12:32. 12:32. So, now you assumed here you just oxygen is considered to be the A and the carbon is assumed to be the B. Okay. When the two elements means here A is oxygen and B is carbon combined together to form more than one compound. Here carbon monoxide is one compound and carbon dioxide is another one compound. Okay. The masses of A means 16 and 32, which separately combined with the fixed mass of B, because here the carbon mass is fixed 12. Okay. In both the case carbon mass is fixed. So, fixed mass of B are in the simple ratio. So, you just consider the ratio of the oxygen in carbon monoxide and carbon dioxide 16 into 32. So, what is the simple ratio? 116 or 16, 2 16s are 32. So, 1:2 ratio. This is called as simple ratio. So, this law is known as law of multiple proportions. I give you another one example, sulfur dioxide SO2 and sulfur trioxide. Here the oxygen present in both cases differ. How it is combined? Okay, here the sulfur is fixed mass. In both the case the sulfur is a fixed mass, but the oxygen is differ. So, you just see the number also, it's enough. So, oxygen is present in sulfur dioxide is 2. In oxygen present in sulfur dioxide is 3. So, the whole number simple ratio is 2:3 ratio. So, next topic, the law of reciprocal proportions. Okay. So, the law is proposed by J. Richer. If the two different elements combine separately with the same weight of third element, just assume the example here, CH4 is the methane and the carbon dioxide. Okay, CO2 is the carbon dioxide. In this case, hydrogen and oxygen is considered to be the two different elements. If the two different elements combine separately with the same weight of third element, because here the carbon masses you consider here 12. In both the cases, in methane and CO2, in both the cases the mass of the carbon is equal to 12. So, that is why if the two different elements combine separately with the same weight of the third element, the ratio of the mass in which they do so are either same Okay, you assume that CH4 is the combination of the carbon and hydrogen. CO2 is the combination of the carbon and oxygen. So here the carbon mass is 12. Each hydrogen possesses atomic mass is 1. Totally 4 hydrogen we have in this compound. That is why the mass of the hydrogen is equal to 4. The next one is carbon, same. The mass number is 12. Oxygen mass number is 16. Totally 2 oxygen is there. So 16 into 2, 32. So 12 is to 32. What is the simple ratio? Means 3 fours are 12 and 1 4 are 4. So 3 is to 1 ratio. The simple ratio of methane is 3 is to 1. Same carbon dioxide, the simple ratio. Okay, 3 fours are 12 and 8 fours are 32. So 3 is to 8. Now you assume if the hydrogen and the oxygen both of them is combined, which ratio? Means the same ratio which is present, because both the elements having combined with the equal weight of the third element. Okay, so which means the hydrogen and the oxygen ratio is also similarly combined with the same ratio. The ratio of the masses which they do so are either same or otherwise simple multiples. The ratio உடைய multiples. Okay, இருக்கலாம் அப்படிங்கறாங்க. Ratio which they combine. So in methane and carbon dioxide, in both cases hydrogen and oxygen is assumed to be the two different element. Okay, those two different element can combined with the same mass of the third element. Here the same third element is carbon, because in both the cases carbon is present in equal mass. Okay, now how the hydrogen and the oxygen is combined means the same ratio, which means here the hydrogen ratio is 1, oxygen ratio is 8. Suppose if hydrogen and the oxygen is combined each other, means it definitely combined as 1:8 ratio, or otherwise the multiples of the ratio. You assume that water, the molecular formula water is H2O. Okay, how many hydrogens are there? We have a 2 hydrogen. What is the mass of the hydrogen? 1. So totally 2 hydrogen is there. So 2. Oxygen mass is 16. So 2 is to 16. Hydrogen and oxygen combined in the ratio of 2 is to 16. What is the simple ratio? 1 and 8. Now hydrogen and oxygen is combined which ratio? 1:8 ratio. Okay, so this law is known as a law of reciprocal proportions. The next one is Gay-Lussac law. So this law is explained about the combining volume of the gases. Okay, whenever the gases react, the volume of the reacting gases and products bear a simple whole number ratio. Okay, அது எப்படி combine ஆகும்? Whenever the gases react, suppose A and B, both of them is gases, A plus B combined to give a C means, okay, here C is the product. So what is the ratio of the reactant and the product? Means they do all in the simple ratio, simple whole number ratio, fraction la varadu. Okay va, simple whole number ratio, provided all the volumes are measured at the standard temperature and pressure, because temperature and pressure has been changed means the volume is also changed. Okay, so whenever the gases react, the volume of the reactant gases and the product are present in the simple whole number ratio, fraction la irukadu. For example, here the hydrogen and oxygen combine to each other to form the water. Here what is the ratio? 2 parts of the hydrogen can combine with 1 part of the oxygen, and it will give the 2 part of the water. So the whole reaction ratio is 2:1. So it is a whole number ratio. The next one is another one example. Nitrogen and hydrogen, both of them combine to form ammonia. Okay, so here reactant is nitrogen and hydrogen, the product is ammonia. So what is the simple ratio? 1:3:2. So it is the simple whole number ratio. So this law is known as a Gay-Lussac law. So the next topic is quantum numbers. So what is mean by quantum numbers? The quantum numbers is used to describe or distinguish the arrangement of the electrons in the cells. Okay, the quantum number is used to describe the arrangement of the electrons in the cells. So you know that already main cells K, L, M, N are there. Okay, so arrangement of the electron is also you know formula 2n square. You can using the formula of 2n square, we can easily accommodate the maximum number of electrons present in the particular cells. Okay, but in atom the subcell is also available. Okay, but in this lesson we doesn't discuss about the subcells, because higher studies pona nee 11th 12th and mari ponaina definitely nee vandu subcells பத்தி படிப்போம். Okay va, so appo the quantum numbers is used to describe or designated the arrangement of the subcells and main cells, arrangement of the cells and also the electrons. So we have the four type of quantum numbers. Okay, so the first one is a principal quantum number. Principal quantum number, which is known as a n. Okay, so the principal quantum number is used to describe the main cells, arrangement of the main cells in the atoms, like a K, L, M, N. But the principal quantum number is labeled in the symbol of n, which is used to describe the arrangement of the main cells in the atom. The next one is azimuthal quantum number, or otherwise it is known as subsidiary quantum numbers. So this quantum numbers is labeled as a L, which is describe the subcells. I already told you every main cells have the subcells. So the subcells are known as a SPDF. இதெல்லாம் நீ higher studiesல டீடைலா படிப்ப. ஓகேவா? So the azimuthal quantum number is used to describe the subcells. It is labeled as L. The third quantum number, magnetic quantum number. So the magnetic quantum number is used to describe the orientation of the orbitals, because the orbital is arranged in the three dimensional. Okay, orientation means how it is arranged in the space. Okay, orbital arrangement in the space is called as a orientation. So the magnetic quantum number is explain the orientation of the orbitals. The last one is spin quantum numbers. The spin quantum number is labeled as in the symbol of S. So it is explained about the spin of the electrons. Okay, the electron is spin rotate itself. Okay, so we have a two kind of spin. One is a clockwise rotation and another one is anti-clockwise rotation. So the spin quantum number is explained about the spin of the electrons. So these are the four important quantum numbers. Okay. Okay students, you have completed the first lesson, atomic structure, go through all the things. Okay, so and completed all the worksheets sent to you. ஏதாவது doubt இருந்ததுனா clarify பண்றதுக்கு further contact பண்ணுங்க. Okay, thank you.